The next example problem is a lead code problem called the bag of tokens. So we have a initial power value P and the initial score of 0, and we have a bag of tokens. Each token has a value, an integer value. And we play a game which we can make two kinds of plays. First is we can play a token face up. But if we do that, the requirement is our current power has to be at least the value of the token. Then by playing this token face up, we lose this amount of power, but then we gain one score. So you can think of the game, initially we have the bag of tokens. The tokens are all in the bag. And then we can decide to pick a token and then play it. We can play it face up. Then we have to spend power, but we gain one score. We can also play a token face down, in which case we will lose one score. So our current score has to be at least 1 to make that play. But we will gain the token's value in terms of power. So each token can be played at most once, and it can be played in any order. And we don't have to play all the tokens, so we can leave some tokens in the bag. So the goal is to maximize the score we can get. So make sure you understand the rule of the game. The token can be played in two ways. Then let's look at the sample at the bottom of the slide. So say we have 5 tokens with values 100, 200, 300, 400, 500, and our initial power is 300. So what can we do? We can play the first token face up. Then we get 400. Our point becomes 200, and then we gain 1 point. And we can play the second token face up, and then our power becomes 0, but our score is 2. And at this point, we cannot make the first kind of play. We have to play tokens face down. So which one do we pick? It should be pretty obvious that we should pick the 500 one. Well, I guess in this case, actually, it doesn't matter that much. But intuitively, we are losing 1 point, but we are gaining some power that we can use to play other tokens. So we might as well gain the maximum power possible. So let's say we play the 500 face down, we gain power 500, and then we can play either of the the other 2 tokens face up. So then we gain eventual score of 2, and then we have 1 token left that we cannot that it doesn't help to play. We cannot play the face up, and play it face down will only make it worse because that will losing one score. So how do we compute this for arbitrary input instance? So for this input instance, answer is 2. So the thing to note is that we are basically trading token values for points. So we can, in some sense, sacrifice a token, and then we gain the power. Then we can play other tokens. So since our goal is to maximize the score, we should play the token with higher value face down so that we can gain more power. And then we should play the tokens with lower value face up, because we gain 1 point from each tokens. So we might as well spend as little power as possible. And we can use exchange argument to prove that these are correct. So when we play things face up, we should play the one with the lowest value. When we play things face down, we should play the one with the highest value. So then these suggest the greedy approach. We sort the tokens, and then we can iterate, try to gain as much point as possible from tokens with small values. And when we run out of that, then we can put 1 token face down, put 1 token with the maximum value face down. But we do that only when there still exist unused tokens, because otherwise we're losing 1 point without gaining anything. And so long as there exists any unused tokens, we know by putting this token with the maximum value face down, we are able to play at least one more token face up. So we're not losing any point. The score -1 can always be recovered. But if there's no all tokens have been played, then we shouldn't do that. So that's pretty much the logic. So this is my code, which is slightly different from the logic in the slide. I do a 2-pointer loop, and in every iteration, at least one of the pointer will move. So I point to the beginning, point to the tokens with small values, and J point to the end, the token with the big values. So they're sorted in the beginning. And for each iteration, if we can play a token face up, we do that. So we subtract power, we increment 1, we increment score. On the other hand, if we have score greater than 0 and I is less than J, so then that means, so I points to the next token not yet played, and J also point to the next token. So if we play J face down, then so I is less than J, so we still have I, we still have one more token, at least one more token to play. So that's a condition checking that there's still a token in the bag. So in that case, we increment our power and then subtract score and then move the pointer. So if neither condition satisfies, then that means there's nothing we can do. So there's nothing to gain, we stop. So it's a greedy approach, but it sort of use 2 pointers to implement the greedy approach.